Hello, this is John from caveofprogramming.com. In this tutorial, we're just going to look at a few little things that we can do just to improve the look of this fractal. So, although we're going to change some of this code later on, it's still nice to work with something. Well, actually, this is one that I've shifted to the left a bit while I was experimenting, but it's still nice to get it to look, a little bit good at the beginning. Otherwise, it's kind of takes some of the fun out of working with it. So one thing I'm going to do here is if we actually run this code now, so the head, what we call the head of the Mandelbrot, because it looks like the head of an insect or something, is actually chopped off. So it looks like this at the moment, chopped off the head on the left there, if you can see that on the video. So we can just, here's the x coordinate, so we could just subtract temporarily just a little bit of a hack from the x coordinate to sort this out. We're going to rewrite this Zoom code later on and make something much more powerful, but that'll do for the moment. So now it looks like this. Now it's all on the screen. Another thing, and this is quite an important point in a way, is that we're scaling the x and y dimensions by different amounts here. So we still get something that's like a Mandelbrot, but it's actually squashed because the x coordinates have a much greater range than the y coordinates, just because I made my bitmap wider than it was high, like most computer screens. But that means that if we kind of take the fractal, which we can think of as existing in a sort of perfectly square type space, and then we compress it or stretch it to fit the screen, and the screen's wider than it is high, we're not going to get like is the word canonical? Canonical? I don't know. We're not going to get anyway the normal view of the Mandelbrot that you see. So to do that, I'm just going to make the x and y scaling factors identical, and as long as it fits on the screen, we can see it. This means that we're not going to get something that's squashed or stretched along either of the dimensions. Let's take a look at that. So, well, that looks good, but now we've got more of it chopped off. So, well, we could do all kinds of things about that, really. We could try putting in height for both of them. If this doesn't work, I'm gonna just play around with this a bit, and I'll show you the results in the next tutorial. But the thing that I really wanted to point out was just that, yeah, there we go, that looks better. It's just that it's good to not stretch it or squash it by applying different scaling factors to the x and y axes. Okay, so now we've got the whole thing on the screen, and we can improve the colouring a bit before we get seriously into that whole area by doing something which I kind of discovered half by accident and half because I thought about it a bit. But what we can do is just let's take this red here and replace it with colour for a start, because this obviously isn't being used just to represent red like I kind of thought temporarily it might be when I was just coding it for this tutorial. So we'll make it say colour, and we can make it, for example, green. I'm just picking green because it'll show up well, hopefully, in this video. Nice bright sort of colour. One thing we can do, so this code is the same as before, but if we take the colour and we set it equal to, like colour times colour times colour, that's going to make it change more rapidly. And although, if we took, let's say, 255 and multiplied it by itself 3 times over, cubed it, that number obviously wouldn't fit into the 0 to 255 range that we have for our colours. But that's not a problem here, because the colour is a uint 8 underscore t. So no matter what we do here, we're going to end up with something that has a maximum possible value of 255 anyway. It has to range from 0 to 255 because that's the range of this type. So no matter what happens, what we do kind of down here, it's still going to work in terms of the program. It's only a question of whether it looks good on the image. So we can mess around with this pretty freely, and we're not going to overflow the bounds of the maximum limit of the color or anything like that, and that improves it. It improves it quite a bit. I do like this image. If you run this for yourself, you may be able to see this on the video. We can see some banding around this area. I don't know if that will show up on this video so well, but we can see a lot more detail of these sort of almost like tentacles that come out from the fractal, and it's really interesting to zoom in on those, which we're going to do later, and you get to see more and more detail. So if you want, you can really have a lot of fun even at this stage, just playing around with the colours and seeing what works. So you can do a lot with this and change the colours how you want. Any kind of colour scheme you can think of that might map this number of iterations to a uint8_t type, you can have a go at it, and that's a really good thing to play around with, because it's kind of a fun sort of exercise. Okay, so we'll leave it there now, and then in the next tutorial I think we'll get on to starting to put in place some of the code that we need to really colour this a lot more nicely. So until next time, happy coding.